And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. And some interesting stuff to talk about today. Let's get right into it. First thing we're doing is we're looking at the sun here. This is the 131 angstroms, and thanks to you new commenters out there. One of our commenters yesterday asked us the difference between the magnetogram and the AIA images. AIA images are showing a very specific portion of the ultraviolet light spectrum, where the magnetogram is using a series of different features to determine magnetic polarization of portions of the surface of the sun. So this one here is a very specific band of the UV spectrum, ultraviolet light, 131 angstroms. You can see a sunspot there in the northeast, right up here. The only sunspot, it is beta class. There is some chance of additional solar flares here. The likelihood of significant coronal mass ejections headed toward the Earth is actually quite low. Here's 304 angstroms, another portion of the ultraviolet light spectrum. This one here is ionized iron, one of the ionized spectral states of iron. This is helium, 304 angstroms. And we've got some more brilliant views of the sun for you. We're going to save most of those for the end of the video. Here's a diagram of the solar system. Happy new moon, my favorite phase. Did you sleep well last night? Well, people have a tendency to sleep better at new moon. This could explain some of the myths about the dangers of full moon. In any case, there's where we expect stuff to be in 1 week in the solar system. Here's a diagram of the stars. And if you're up before dawn and you have clear skies, you may see Saturn as well as Jupiter rising ahead of the sun. I like to draw in the ecliptic on my star chart. Moving on to the radio flux. So the radio flux is the output in radio frequency from the upper chromosphere, which is just the outermost layer of the local yellow dwarf right here, and the lower corona. This area puts out radio. That's why we made this animation. The 10.7 centimeter radio flux now at 77. So here's that in context. The black line here is the radio flux. The red line is the sunspot number. A bit of a lull in the ramp up into cycle 25. If you haven't watched our video about the solar polar fields, perhaps check that one out. And we've seen a dud of a forecast here so far for the incoming coronal hole wind stream right now. We have not seen geomagnetic storm conditions hit. A geomagnetic storm of a G1 class, a KP of 5, as you can see here, was forecasted by NOAA. We made it to a KP of 4, and it looks like a late arrival so far. We did see the incoming solar wind density make it all the way over 40 protons per cubic centimeter. We'll get to that momentarily. First, volcanoes. If you're wondering what's erupting, here's a list. Sakurajima is producing a 7,000-foot ash plume. Suwanosejima, a 5,000-foot ash plume. Raung, exploding as well, 14,000-foot ash plume there. Sinabung, 12,000-foot ash plume there. Semaru exploding, 14,000-foot ash plume there. Dakono exploding, 7,000-foot ash plume there. Popocatépetl exploding, Pacaya exploding, Fuego exploding, Sangre exploding. Ash plumes between 21,000 and 12,000 feet at those Mexican, Guatemalan, and Ecuadorian volcanoes. No volcanic ash seen at Revenador. Please do not build a campsite on the lower slopes of the Ecuadorian Revenador volcano. And Sabancaya once again exploding, producing a 27,000-foot ash plume. Don't pole vault the caldera. It may affect your ability to watch tomorrow's daily space weather video. Now check it out. We see a weird earthquake here in the Northern Territory of Australia at a 4.4 magnitude. That one happening just before 2 p.m. Universal Time yesterday. Anyway, let's go up the whole list here. It looks like a fairly light day of earthquakes over the past 24 hours. One of the largest was off the Kamchatka Peninsula. There is one in the South Atlantic as well. One of the largest of the past 24 was this 5.6 at Greece. Looks like it may have caused some damage. There's the location of that. Grecian 5.6 magnitude earthquake. May have been the largest of the past 24 hours. We're just going to scroll up the list here. It looks like the deep quakes have ceased. We reported quite a few of them yesterday. Here's a 4.8 at Guam at depth. Leave us a comment if you're viewing from Guam. And if you're U.S. military personnel, thanks for your service. Here's a 4.3 at Fiji as well. That one over 600 kilometers depth. And again, a 4.3 magnitude. Another deep quake struck Indonesia, 4.6, 171 kilometers depth. Small deep quake struck Dominica. Once again, another Caribbean quake at a 3.5 magnitude, just over 100 kilometers depth. Another deep quake at Fiji there, that one coming in early this morning at 1:53 Universal Time. That 4.4 magnitude quake at over 560 kilometers depth. Some quakes at Hawaii as well. Let's check the location of this 3.3. Off in the Pacific Ocean. Well off the coast of Hilo there. You can see the location of that one where that star is. Northeast of Hilo. And let's check this 3.4 as well. Similar location there out in the Pacific Ocean. So the largest of the past 24 was that 5.6 at Greece. There was a Central American quake as well. More recently, this one coming in at just before 8 o'clock Universal Time, a 5.0 at over 163 kilometers. And here's another deep quake happening while we did show prep here, a 4.6 near Fiji at 532 kilometers depth. So quite a few deep quakes there actually on today's list. No major solar flares. We did see a B-class flare. That one peaked right at 1900 Universal Time yesterday. So 7 p.m. Greenwich Mean Time, 7 p.m. Zulu Universal Time, whatever you want to call it. We saw a small B-class flare, which I believe was indeed out of sunspot 2808. And we'll continue on here in a moment. Let me just check the life of the stream, and everything looks just fine. Here at the Smash News Network, we prefer to provide objective, realistic information, like the proton flux, which we don't see any spikes in. And we would have let you know ahead of time if there was going to be a spike in the proton flux. Well, we hope so. Sometimes coronal mass ejections take as little as a half an hour for the protons to arrive, folks. No arrivals have happened. There's the 3-day chart of that. And it's been a long time since we saw a spike in the proton flux, indeed months. GOES magnetometer over the past 3 days is looking a little spiky over the past 24 hours. You see these big spikes at midnight. And again, there is a coronal hole wind stream making its way to Earth right now. It's part of it has already arrived, and we'll be keeping you updated on that. We may make another video later today, especially if we reach into geomagnetic storm conditions. Here's a diagram of the heliospheric current sheet. You can see the Earth solidly in the red portion here, which is the South Pole oriented current sheet. I would suggest that we may see some activity rising here in the southern hemisphere. You can see right there that North Pole polarity popping through could be an indication of rising activity. And if you want to look into that, go check stereo A, which by the way is represented here. That's stereo A at Lagrangian 0.5. Here's stereo B at Lagrangian 0.4. Next we'll look at the coronal hole line of sight plot. This shows you the sun's B field, And you can see some shifting here of this blue portion. That's the sun's B field. And the sun is certainly taking its good old time performing its cycle 25 solar polar field reversal. And if you want to see what was going on with this about a year ago, we've got a video about that. It's in the Cosmology segment as well as in the Daily Space Weather Videos playlist. youtube.com/smashamash/playlists is where you'll find that. And let's go to the real-time solar wind. So here you can see we peaked out at just over 40 protons per cubic centimeter there, the initial front of the incoming coronal hole wind stream. And you can see this dip down as the velocity came up, but now it's coming back up again. So this is sort of a double pulse here. And the shape of that coronal hole, the south pole oriented coronal hole that's providing those protons, is probably to blame for that. And coronal holes are essentially low pressure zones on the sun, which create high pressure zones from our location once the protons arrive. So in any case, we see a significant uptick here in the solar wind density from yesterday, currently at over 22 protons per cubic centimeter. Solar wind speed not so elevated here, not even 400 kilometers per second, so expect a significant uptick in that as the coronal hole wind stream strikes in earnest. I wouldn't be surprised to see geomagnetic storm conditions as a result of this. We also saw the BTBZ just recently shift into positive territory, so we see pretty high readings here. Indeed, the scale expanded. So current conditions with the BTBZ are a BT of 10 and a BZ of positive 10. So some North Pole-oriented magnetism there, as reflected in that BZ at positive 10. That means that the North Pole, the North Solar Polar Field, contributing to the majority of the total field. Phi angle has recently shifted as well. And we see the solar wind temperature leveling off here over the past several hours. So there you can see the KP index has actually come down off of its highs of geomagnetic unrest, a KP of 4. And for you new viewers, thanks for tuning in, that is a measurement of global geomagnetism. Here's a geospace magnetosphere movie showing density. And this might be a little bit deceptive, folks. Keep in mind the dark blue is showing you high density. The white is showing you low density. And you can see that high density all around the local portion of the planet right now, a result of that high density incoming solar wind. Don't let the colors fool you. Blue is high density. Here's the pressure. And it's no surprise to see some high pressure here. Expect to see the density drop back off again and the velocity come back up to higher speeds here. No forecast on what it'll be, but coronal hole wind streams tend to include a much higher solar wind speed than 380 some kilometers per second. These are both 4 hours of data. Next, looking at ground magnetic perturbations, here's the view from the poles. And we don't expect major auroras to be kicked up from this yet. Although when the high-speed portion of the solar wind shows up, we may see some auroras. And again, we may do another video about that later today. So you can see this ramp down here over the past couple of hours. We're looking at delta B, so changes in the Earth's B field is what you're looking at here, folks. And since we're living a geomagnetic excursion, we show this 4 hours of data daily to show folks where magnetic perturbations currently are happening. And again, this is like the other geospace magnetosphere movies, 4 hours of data. By the way, we are streaming live to Twitch thanks to our viewers over there on Twitch. Consider picking up their mobile app as well. It's twitch.tv/smashamash, a fantastic mobile platform. If it's good enough for gamers, it's certainly good enough for these type of videos. And if you're viewing on YouTube, don't forget to press like and subscribe over on YouTube. No, that's okay. We'll wait. Press like and subscribe. Press the share button and share on your social media. If you're an influencer, drop us a line. We'll be more than happy to feature your channel, perhaps vice versa. And help us to get out of this 1750 to 1740 algorithmically induced slump of BS. Here at the Smash News Network, least busted name in news. Probably why we see our subscribers mysteriously oscillating between 1,740 and 1,750 subscribers for now pushing 2 weeks. I'm sure it's perfectly organic, folks. I'm sure it's got nothing to do with algorithms, right? We're also on BitChute. We have exclusive content there. And sorry to our BitChute viewers. BitChute was experiencing technical difficulties yesterday, and we did not upload our video. So make sure you subscribe over on YouTube, wherever you're viewing, as we have vastly more content uploaded to the YouTube platform because it's so feature-rich. Today's featured product is the Fauci Committed Fraud products. Perhaps you'd like to place your feet on Fauci's face every time you get out of the shower. If so, perhaps pick up a Fauci Committed Fraud bath mat. You can find all of that at our homepage, smAsho.com. You can find our social media links there. And that would be in the smAsho merch shop if you want to pick yourself up a Fauci Committed Fraud bath mat. I don't know when he's going to shut up. And shout out to Mr. Keebler. Shut up, Fauci. Fauci, shut up. By the way, we have a lengthy coronavirus section at smashamash.com/forum. If you haven't checked that out, I just updated it only, well, it was more than 16 seconds ago. It was actually 20 minutes ago. But there's been an update in the coronavirus section of the forum. If you want to see what was going on a year ago today, yesterday was the anniversary of the declaration by the WHO of a pandemic. Check it out at smashamash.com/forum. You can also find links on our homepage to our Discord channel. There's our Discord channel. There's a permanent invite link there on the Discord channel. So go check that out if you haven't already done so. And let's do a cosmology segment. Some interesting stories came out today. And here at the Smash News Network, we like to cover them. Allow me to remove myself. So today's cosmology segment, we've got 3 different stories. One, how about organic material returned by Hayabusa 1? So you may be familiar with the concept of panspermia, the idea that perhaps life on Earth came from space, the place where all your weather comes from. And organics were found on the asteroid samples. So there were some burned portions of it where the asteroid was heated up to over 600 degrees and some other spots where it wasn't. And we see organic compounds on that. This article is from Unrest today. And there's an image of some of the material returned from an asteroid by Hayabusa. Well done. Again, it's on universetoday.com. And we're going to look at a random object today. So let's pick a random number using our quantum random number generator here between 1 and 1031 to coincide with an object at the Neil Gorell Swift-Bat X-ray Observatory. Today's random quantum number is 371. So let's consult this and figure out what 371 is. 371, and there's lots of stuff to study here, folks, is 1A1118-61, a high-mass X-ray binary / neutron star. We'll just refer to it as a massive radio source. And check it out. Here's an interesting feature. We saw a massive X-ray outburst here around 2008. It's otherwise a little bit more consistent than that, but that was a major outburst from 1A1118-61, a catchy name. Here's the 30-day chart, and we actually saw some pretty dense emissions from it here over that period. And let's take a look at it on SIMBAD, see if we can give you a visual of 1A1118-61, and there it is on SIMBAD. Let's go to Aladdin Light. You're looking at actually visible light there. Let's bring up the 2 mass to view it in infrared. Oh, that must have been infrared. Okay, anyway. Here it is in red light. And it's a pretty bright object there. How about in blue light? There it is in blue, and that often shows additional features there because of the diffusion of red light versus blue light through the interstellar medium. Here it is on Chandra. And the Chandra X-ray telescope giving us some insight into that. It's a pretty oblong-shaped low-mass X-ray binary / neutron star. Today's random featured object is 1A1118-61. Again, a catchy name. And you can follow your own favorite transients if you like to at the Neil Gorell Swift-Bat X-ray Observatory. It stands for Burst Alert Telescope. And if you're interested in, say, I don't know, Sagittarius A star and what it's been doing, just search for SGR space A, and you'll find it. There are the transient X-ray outbursts from it. And while we're here, let's take a quick look at Cygnus X3. And if you want to read more about Cygnus X3, aka Deneb, celestial pole star at the other end of the precessional cycle, go to smashomash.com/forum to the Cosmology Forum, and you will find an entire thread just about this high-mass X-ray binary, consisting of a thing like a neutron star or perhaps a black hole, or some people even think it's a quark star, orbiting a massive blue supergiant known as Deneb. It's just the brightest intrinsic object visible from our solar system, at least in the Milky Way galaxy, Cygnus X3, high-mass X-ray binary. And there are the current transients from it. And we've seen the scale here expand. You can see this goes all the way up to 0.2, which is well off the historic scale. It would be way up here someplace. So we saw a major burst from it just a couple days ago in X-ray. Cygnus X3. And one more story. How about a wandering supermassive black hole? How do we know? Well, masers can tell us about the motion of a black hole. So the supermassive radio source at the core of galaxies can be moving. And we found one that's moving. It's the one at the core of this galaxy right here. So a maser is kind of like a laser, but it's in microwave frequency instead of visible light. And this galaxy, known as J0437 plus 2456, appears to have a moving supermassive black hole. We'll call it a massive radio source. And it's not clear as to what's causing it to move. Is it a binary supermassive radio source at its core? Or is it still reeling from some sort of a merger, perhaps with an additional supermassive radio source? And I think you'll find this one on multiple science wires. We took the article from SciTech Daily about the possibility of a moving black hole. It's looking like it indeed is moving with respect to the rest of the galaxy's motion. And again, it's not clear as to why it's moving, whether it was a result of some sort of a merger, or if it currently has a similar mass companion. Not exactly sure on that one, but masers help us to understand that. Microwave, it's essentially a microwave version of a laser. So it's photons stimulated by emission of radiation. And that's today's Cosmology segment. Let's move on to additional data, like the electron flux. So here's the one-year chart of the electron flux, and we've seen a dip, as we typically do, characteristic of coronal hole wind streams. So there's that cratering of the electron flux, as we typically see with coronal hole wind streams. No real surprise there. And we'll expect to see an uptick in this once the coronal hole wind stream subsides. But there's a 3-day chart. Briefly made it into warning territory yesterday. Not a big-time electron storm or anything like that. And here's the forecast. I would expect the forecast tomorrow to be a little bit lower than that, maybe down here. And I would expect this forecast to be higher than that, maybe up there. The green boxes are the forecast by NOAA. The yellow diamonds are the observation. Here's a visualization of the total electron content. And this will show you where GPS errors are. For you new viewers out there, GPS errors are much more likely to occur around the equator at noontime. And we may see anomalies as these get more irregular with very low levels of electron flux than very high levels of electron flux. We saw some brief areas of a little bit high density right around here. And then a sudden ramp down to the density. Something that we typically see with low levels of electron flux. Something that coronal holes have a tendency to induce. So here's a diagram of just the atmosphere. The F layer right here, that's the F ionosphere layer around 300 kilometers. That's where the GOES 16 makes its measurements. And here's a visualization of just the ionosphere layer. And you're looking at vibrational frequency here. So the resolution is only 1 megahertz, folks, which is 1 million vibrations per minute. We may have some missing data there. Some oddities. Looks like we see some missing data here in the ionosphere animation. Never saw that one before. But that does not indicate oddities in the ionosphere itself. It could just be problems with the data itself. This one is by Australian Government Bureau of Meteorology. There's a latest image which is actually looking a little bit anomalous here. A highly charged up region here, stretching really far to the south, as well as the highest frequency portion right there up to 14 megahertz, pretty far south there, right at the coast of Alaska versus Madagascar. That image from 10:30 Universal Time. Here's the jet stream. We're going into meteorology realms now. Here are the jet streams of the Western world. Tripled up jet stream here in the Southern Hemisphere, as well as some backward motion over northern South America. Jet stream blowing east to west is opposite the normal direction. Here are the jet streams of the Eastern world. And it looks like we see a further breakdown of that cyclonic system in the southern Indian Ocean. Now no signal at all at the jet stream level, although still a significant cyclonic system there in the southern Indian Ocean. Once again, there's the 250 hectopascal winds. And I would note once again that the jet stream blowing backwards across the western Pacific and equatorial Indian Ocean. Snow forecast remains for 4 feet of snow in southeastern Wyoming and north central Colorado. That is 4 feet right there. 48 inches of snow forecast through 12 Universal Time. So that's 7 a.m. Eastern Time, which would coincide with 5 a.m. local time there. And then also a sudden 8 inches of snow expected to fall in places like southern Minnesota and northern Iowa. So this is getting more likely here. This is the GFS forecast. On Tropical Tidbits, you can view it yourself, tropicaltidbits.com. Next, looking at windy.com. And we actually brought up low clouds here. Just give it a minute to populate the map. And it's not going to cooperate. That's kind of odd. Anyway, let's go to pressure. Here is the It's supposed to be the pressure map. What is up with that, Windy? We're streaming live here, Windy. You're cramping our style. All right, here's the pressure map. And let me just check the life of the stream here to make sure we don't have any bandwidth issues. And everything looks kosher here at the Smash News Network. So here are pressure cells now. We see this low over, centered over the Texas stovepipe. And we'll advance this into tomorrow. There's where we expect pressure cells to be at noon. You can see that pressure cell intensified there, near the Colorado-Kansas border, is about the center of that at noontime tomorrow. Continuing on to lightningmaps.org, we saw some terrestrial lightning here. We were tracking it before we did the live stream. And lightningmaps.org may be still experiencing some data loss. So if it's looking incomplete to you, check out blitzortung.org, which does power lightningmaps.org in the first place. They really are sister sites. So here's your global lightning map. We saw some significant lightning here across Australia over the past, I think this shows 6 hours. No, it's only showing 120 minutes, so 2 hours. Anyway, it looks like things have subsided a bit in the U.S. Here's the lower 48's cloud map. It's too dark to see them with the visible satellite, so we use the shortwave radiation 3.9 nanometers, channel 7 on the GOES East. It's the NASA GOES interactive weather satellite. Here's the water vapor map, which should give you additional insight if the Doppler is not helping. Again, there's the water vapor map. There's the cloud layer. Quite a bit of moisture there in the central U.S. No counterclockwise rotation yet. And again, here's the U.S. Doppler radar map. Some heavy storms there over southern Missouri, northern Oklahoma, about to move into places like Kentucky, southern Indiana, northern Tennessee. And some snow falling in places like central Arizona, Utah, and western Colorado. Next, I'd like to thank our patrons, the true source of funding for the content. Thanks everybody who submitted questions to our upcoming possible guest. If you want to know who it is, maybe become a patron at patreon.com/smAshomash. If you want the earliest alerts about everything from solar flares, sunspots, coronal mass ejections, electron flux warnings, geomagnetic updates and alerts, patreon.com/smAshomash is where to get all of that stuff before anybody else. Ask our patrons, they'll agree. And let's go to bonus features. Here's what Sunspot 2808 looked when I did show prep. And it's degraded a little bit here. Still a beta class, but barely. So there's the magnetogram. And there's the intensitygram. Let's press refresh to see the latest. Has it continued to degrade? And indeed it has. This is about to be reclassified as an alpha class sunspot as the trailing opposite polarity umbrae have shrunk. So we may see this downgraded to a beta class sunspot today. That would be no surprise. And we've got additional bonus features here, including the full disk imagery of the local yellow dwarf in 2 different wavelengths, 2 different ionized iron emission spectral states. So we're going to show you 193 angstroms, 171 angstroms, and then we're going to close this thing out. 193 angstroms is very good at showing coronal holes. So you can see significant coronal hole up there in the north, as well as another one rotating in. That one is south pole oriented. The one that's currently striking the magnetosphere is this one right here. And we may see an ongoing sputtering situation with that. You can see the shape of this is pretty irregular. It is oriented with the south solar polar field. And here's 171 angstroms, my favorite wavelength. Or to quote one of our patrons, the sexiest wavelength. In any case, thanks for tuning into the Daily Space Weather, folks. Remember to check our other playlists, youtube.com/smashomash/playlists. We've got all kinds of other content in addition to this, so perhaps check that out. Remember to press like and subscribe if you enjoy the content. Share with your friends and foes, your science noobs and your science pros. And welcome to the Neo-Renaissance. Visit our links. May that solar wind be at your back and that covidiously absent from your doorstep.